Hello, everyone. Good morning. So welcome to the Business Planning and Analytics webinar for 2025 Western APA. So in this session, we are going to go through the SAP FedML libraries to extract data or to read data or to federate data from Datasphere into one of the hyperscaler environments like Azure Databricks, and bring the data back to SAP Datasphere and reporting on it. So I'll move on to the next slide. So this is the SAP FedML architecture introduced in last couple of months. And in the architecture, you can see basically SAP S4Data, BW, all other SAP applications, cloud and on-prem, supplying the data to SAP Datasphere. And from SAP Datasphere, and you can see SAP Datasphere connected via FedML library to Databricks. In place of Databricks, you can have Azure, you can have Snowflake, you can have Google Cloud or AWS, any of these hyperscaler environments. Using SAP FedML library, you can read the data from Datasphere, process the data in the hyperscalers, and send the data back to SAP Datasphere and report via SAP Analytics Cloud. So what's the FedML value proposition? So why we need to use it? Now, if you go back in history, we said all source systems to send data to a centralized analytics and data environment and a central analytics team dealing with all requests for analytics from any organization. So bring everything into a single place and consolidate it and report out of it. There is a problem. I mean, the problem is the central analytics team doesn't understand a lot of business functions. So there's a lot of information being passed from here and there, and a large or longer turnaround time to deliver a few things. So all these hyperscaler environments, along with SAP, are now proposing a data mesh or a data federation architecture with a decentralized governance framework. For example, if you have a central procurement system sitting in SAP or a non-SAP environment or a central finance system, SAP or non-SAP, then if you have Datasphere connected to it, you don't have to transfer that. If you have another Azure environment, Azure Databricks environment, Azure machine learning environment, then you don't have to send the data. So there's no extraction and migration of data to hyperscaler machine learning platforms. So all you have to do is feed Databricks, in this case, feed Databricks, do your machine learning in Databricks with your data from Datasphere, and then send the processed data back to Datasphere. So in here, this library applies to the data federation architecture of SAP Datasphere and enables data scientists to build, train, and deploy machine learning models in the destination systems. And it also will help organizations avoid vendor lock-ins and aid them with a reduction of their hyperscaler storage cost and, of course, the GDPR policies. So now let's move on to, so just before we go ahead, so what we are doing, basically, we have the data from S4HANA in Datasphere. We are going to read the data in Databricks from SAP Datasphere, apply a machine learning model in Databricks, and feed the data, the predicted data, back into Datasphere and make all of it available to SAP Analytics Cloud for reporting. So I'm moving on to the next slide. Okay, so here I have taken a very, very simple use case, which will help you understand what we are trying to do rather than a very complicated data model where all the focus is on the data model, not on what we are planning to do today. So here I have three parameters or three inputs: TV, radio, and newspaper, and my actual sales from last 5 years worth of data. So let's say every month we spend 230,000 in the first month. We spent 230,000 on TV, 37.8 thousand on radio, 69.2 thousand on newspaper, and what was my sales? Let's say 22 million. Similarly, we have data for every month for last, let's say, 10 years. So we are going to utilize the input TV, radio, and newspaper input data, and the actual sales we already have from the system. But based on the parameters, we are going to, these four parameters, we are going to train the machine learning model and then predict the sales with these parameters and then compare the predicted sales with actual sales. Okay, let me explain this again. So we are going to take the input TV, radio, newspaper. Our target is actual sales, and we'll train our machine learning models with these four input, with these three input and one target parameter. And we'll predict with the three input parameters, TV, radio, and newspaper. And then we'll get the predicted sales. We'll compare predicted sales with actual sales and report via SAP Analytics Cloud. So now the interesting part starts. So what we need is an Azure account. So let me just increase the slide a little bit more so that you can see it. So we're going to set up the first step. We're going to set up an Azure account and create a Databricks workspace. So I'll move over to Azure now. So as you come to Azure, go to the home screen. So you must have an Azure account, and you're more than welcome to take a free account. But here we first create a resource and we call it as Databricks. You search for Databricks here. So now here is Azure Databricks, say create. While you are here, so my account is my email ID, pranab.parhi@gmail.com. So when you create an account, there should be a subscription. By default, it'll take you the subscription. I only have one. Then create a resource group, make a meaningful name. So for example, I have taken here Databricks _Datasphere ds-rg. Then the workspace name, may make, for example, I have Databricks _ds-ws. So you can take example, Databricks _data source -ws, something like a meaningful name. Then region, I'm in UK South, so I've taken the region. So take the nearest region as your Databricks allows you. You can see here lots of regions and lots of data centers are available. And then in the pricing tier, I'm on a premium pricing tier that allows me to do most of the things that I want to do, but you can take a free license as well. Now, let's go back to the slide. If you see here, what we are trying to tell, create an Azure account on Azure platform. Next, create an Azure Databricks workspace. We are there. Now, while creating the workspace, you have to make sure that enable no public IP to yes under networking. The primary reason behind it is your network or your Azure account or your workspace is very secure, and you don't allow external IPs to read anything into your Databricks workspace. Now going back here, so that option is here. Just make sure this is turned to yes. Okay, I already have my workspace. Once you've done this, say review and create. And once you are done with this, go back. So I go back to my home screen. Now let me take you back to my workspace that I've already created. So this is my workspace. So this is how it should all look like. Now the next thing, let's go to the next slide. So next slide is the NAT gateway and the outbound IP. So why we need this? Because we need to, your Databricks workspace must work, must interact with Datasphere, and there should be a safe connectivity, safe and secure connectivity between Databricks workspace and the Datasphere tenant. So we should go to the resource group, and while you are in the workspace, navigate to the managed resource group using the hyperlink. So let me go back to the workspace. So here you are on the workspace. Now go back to managed resource group. So here you are. Now, if you don't see here these parameters, just type in NAT gateway and hit a search, and gateway and hit search. Yeah, it should show you NAT gateway, but look for NAT gateway. You click on this. Then once you are here, you go to outbound IP and make a note of this IP address, because we need to whitelist this IP on our Datasphere tenant so that Datasphere and Azure Databricks can speak to each other and have a safe and secured connection. So I go back to the workspace now. Once you do it, save it, and you're good. Here, the first thing we're going to do here is we will whitelist the IP address and then go to your space in this. So we're here in the Datasphere tenant. We will go to the space in your Datasphere tenant and create a database user. So you don't have to do anything complicated. This is very, very simple. So go back to your Datasphere tenant, go back to, first thing that we're going to do is we're going to whitelist the IP address, go to System, Configuration, and then go to IP list and trusted IPs. Now you can see I already have created so my IP address. Let me go back to the Azure screen. You can see here, let me go again to the managed resource group, NAT gateway. Here I was. My outbound IP was 85.210.156.38, and I have whitelisted that over here. Similarly, you need to add yours. Forget about this 32. Don't enter anything over here unless you have a range. So put your IP over here and just put some meaningful description. That should basically whitelist your IP. Now, go to space management. The next task we have is we create a database user in our space. So my space that I'm going to do the demo is a test space. Here's the space. In space management, go to, so I have access to all the spaces or most of the spaces in this Datasphere tenant. You go to your space, say edit. And once you are here, go to database access and say database users. Once you are in the database user part of the screen, so there is a create thing over here, create button, say create. Now give any name, try and make it small. In my case, my database user is ppdb01. Test is the schema name or the space name. It will prefix automatically. So let's go back again. So let's say ppdb01. This is an so let's say 02. Then you can ignore enable password policy, enable automated predictive library and predictive analysis. And then this one, enable read access with grant option. You can ignore enable HDI consumption. Then you say OpenSQL schema. This is very important, enable write access, because remember what we have to do. We have to read from Datasphere tenant. We have to apply machine learning in Databricks. and then we need to write back with our predicted results or whatever is the process data. We need to write back into Datasphere. So I need both read and write access. So while you hit the create button, it will give you, I don't want to create a new ID over here. Once you hit the create button, it will generate the password for you. Make sure password and few other credentials that I'm going to show now. It will generate all of them. Make sure you make a copy of them because we will need those parameters to connect from Datasphere. So let's say, for example, let's go to my user ID, database user I have created. So I created ppdb01, and then the prefix test hash was added by the system automatically. So it's saying this is my schema, and then it's going to generate the host name for you. So, and the port name. So take a copy of the database user space schema is, the schema name, the host name, the port, and the password. If you have a user ID which was created prior to, whenever you start trying this in your system, you can request a new password just in case if you have forgotten your own password. So now, after this step is finished, you have your database user for the specified space you want to work with Datasphere. But very important, once you finish this, don't forget to deploy it. Otherwise, your database user will not be activated. So once you've done this, the user ID will show, but the status will not be active. Deploy the space, then you have an active database user. Now I go back to the slide. So that's what is there in this slide. Whitelist the IP address from Azure in SAP Datasphere. This is the menu path, system, configuration, IP analyst, trusted IPs. Then create a database user. Keep a copy of the database user credentials, host, port, user ID, password, and your scheme. Then make sure the last, very important step, make sure to deploy the space after creating the user. Otherwise, the user won't come active. Okay, so now what we have our Azure account created. We have our Azure Datasphere Databricks workspace created. And now we need a server in Databricks so that we can run our code. So I'll go back to the Databricks workspace. So basically go back to your Azure account. Now this is the Databricks workspace. Now you said launch workspace. That should open up. Sorry. So go back to, so once you click here, then it should open up the workspace here, like this. So that's your Databricks workspace. In the workspace, you have recents, catalog, workflows, compute. So what we're going to do, and there's marketplace where lots of data providers are there. You can import a lot of data and so on. So let's go to the compute. This is what we are going to create. You are going to create a compute so that you can create your notebook to write code about machine learning and so on. So this is an important step. So once you say create a compute, then a lot of things will come as standard, unrestricted. So let me go back to the slide. So we have primarily 5 things: policy, access mode, Databricks runtime version, node type, and termination time. So if I go back to the Databricks server configuration, leave most of the things as usual. Worker type, given the amount of data, mostly you'll be fine with a standard, what did I take? A standard DS3 version 2 with 4 cores. Yeah, so let's say standard DS3. So go for a standard DS3. I can't find it. So sometimes they're not available based on your reason, but keep a note from the slide. It's a standard DS3 version 2. That's important because it's one of the low profile computing resources available here. But based on your data size, if it's too big, then go for a higher worker time. Then do one thing, or if you go to single node, maybe you can see. Yeah, so this one. So sorry, click on the single node. You don't need a multi-node tenant because your data volumes are much lesser. You're just doing an experiment, so you're good with single node, keep it single user. The runtime version, you don't need to change anything. It takes the latest runtime version, and keep this low because this will decide, or you will incur a higher cost if you take a higher processing unit. Then this one, the final one, terminate after 120 minutes of inactivity, reduce it to 20. Because if you are idle for 20 minutes, or reduce it to 15 minutes, if you're idle, then the server will shut down automatically. So make sure you create this, make these settings and create compute. I'll just cancel it. I already have a compute. So in my compute is this one. So I have a standard DS3v2, as you can see, termination after 20 minutes. This is important because you're going to incur a higher cost. And I'm on a single node, single user, and so on. I don't have any advanced options, so we're good with this. Now I go back to the workspace. Let's go back to the slide. Next, setting up your input data, a view in your Datasphere tenant. So for my use case, I have a very, very simple view. So let me go back to my Datasphere tenant. So I am in Data Builder in Datasphere in my space test, and I have a folder, a little bit of neat work. I have a folder where I have all my artifacts. So I have a table with advert data. I have created a view on the table. So this is my view. The region so if you see the data set that we discussed from the slides, we have record IDs, TV, radio, newspaper. These are all input parameters, and our target is sales. And we are going to train the machine learning model in Databricks using TV, radio, newspaper as our input, sales as the target. And we're going to train the model, and then we're going to pass a different data set and predict sales and evaluate basically the performance of our machine learning model. So here, the view, the reason I came back here, exposed for consumption, make sure this is turned on so that this will enable Databricks to read the data from this view. So in the real world, you might have a much more complicated view connecting many different tables, but that's not our focus. Our focus is to connect Databricks and Datasphere. So I have a simpler view, and my view is ready. This is the output, and we'll read data from this interface. Now, come back here. You have created your compute. So let's go back to, so we created the compute before. Now we saw the view and the data. Now the compute, make sure once you're in compute, you start the compute from here. And once your server starts, this kind of takes a little bit of time. So I started it in the background. So now we go back to the workspace. In the workspace, I've created a folder, Datasphere. Then I've created so many notebooks over here. So if you right click and say create notebook, that should create it for you. But once it's created, then you are here. Now, the first thing that we need to do we will have to install SAP FedML Databricks. So I'm going to, this takes a little bit of time. So I'll start this and then go back to the slide. So the first thing that we need is the starting of the FedML, the installation of the FedML Databricks, and then these are my configuration parameters. Remember when we created the database user in Datasphere, I asked you in the previous step to keep a note of these parameters: address, port, user, password, and schema. So you will have to, I've hidden away our own parameters. So you have to have in this fashion config_json is equal to these ones. So you do a variable. So you have to keep all these parameters. In my case, I just wanted to highlight something over here. You don't have to keep these things or provide these things in Databricks. You can create an Azure Key Vault. I'm not doing it for this course or for this demo. You can create a Azure Key Vault, create secret scope and secrets. So that's where everything is stored as an admin, and then come back to Databricks and maintain a secret scope with details from Azure. So normally in a production environment, these are the things that has to be done so that nobody gets access to, those system config details or connection details. So what I have done over here, let me go back to my Databricks notebook. I have created something, another notebook, Datasphere configuration, and I'm attaching that notebook over here. So at least I've added some bit of secrecy, but while you're doing your test, make sure you're okay to do this, and then you can hide it in either of the ways: create Azure Key Vault, maintain database secret scope with details from Azure, or hide it like me, I've done in a notebook. And I'm saying, so if you go back to my workspace, you can see this one. I'm not opening this, but this one has exactly this code with the connection parameters from the previous step. Okay, now we are back into, so I executed, so now the FedML Databricks has been installed. Now run that code, which has the connections. Now import the required Python libraries, NumPy, Pandas, JSON, FedML Databricks. It's done. Now check, let me just clear this output. So check that the connection is okay. So DSP is the database variable which will get the connection parameters. So here I'm saying check the connection is okay and display the DB connection information. So you can, so these are different parameters: get table size, user table, view by name, and so on. So we'll use one of these parameters to ensure. So let me just clear this output as well. Clear output. So what we're doing here, we're saying data is equal to dsp.schema view and display data. So basically, from here you could see all these methods are available with DSP, our database connectivity. So you can see our view is available here, along with all the views in the space test schema. So read the data and show basically all the views are available. So this has established our connectivity to Databricks, to Datasphere. Now our next step is to read data from our view. So let me just go back to my slide. Reading data from our view in Datasphere. It's a very simple Spark SQL. So here, if I clear the output and run this again, so we are saying Spark. So this is the Spark data frame. We're saying dsp.execute query by Spark, select star from test.advert_001 v001. And this is my data. ID, TV, radio, newspaper, and sales. Now for machine learning, I got some errors. So it doesn't take the machine learning model that I'm using does not take PySpark data frames for whatever reason. So I converted this to pandas data frame. So we'll just run this again. So we have now the pandas data frame giving us the look and feel is the same. It doesn't do much. So it's a TV, radio, newspaper, and again, my actual sets. And again, I had a different error with float. So I converted all of it to decimals. Now, let me go back to the slide. We will discuss few fundamentals about machine learning. So this is an important this is the important concept for people who are new to machine learning or who are new to the details of machine learning. So we have our data, record ID, TV, radio, newspaper. I have my actual cells. So normally the input in the machine learning world, the languages they tell them as features. Features are the input variables used to train a model. They are characteristics or properties of the data that help the model make predictions. Now, actual cells is a label and the output or target variable that a model tries to predict based on a set of input features. So we have our actual cells, we have our TV, radio, newspaper as our features. We will implement a machine learning model to learn from this data, and then we'll provide it a new set of data with only record ID, TV, radio, newspaper, and we'll ask it to predict the cells. So, but some more fundamentals. So in machine learning, there's something called a supervised learning and an unsupervised learning. Supervised learning, in our case, we have a supervised learning where there is an input data set. So TV, radio, newspaper are our inputs, and the label actual cells is the output. And the machine is going to learn, the model is going to learn from this data set. Unsupervised learning is where a model is given only input data and find patterns without labeled outputs. You can have actual cells, but it's the model. You might have more measures like actual cells, then tags, then gross cells, and so on. The model is going to find the hidden structured relationship between the data. But in our case, we are going to use a supervised learning. So we're going to use TV, radio, newspaper, predict actual cells. Sorry, yeah, we have that and train the model with actual cells and then predict the cells and then compare the values between actual and predicted to see how our predictions are doing. So we move on to the next slide. So here, our next step is prepare the data for your machine learning model. Now, this may look a little bit complicated, but if you focus, what we're trying to do over here, we have our whole data set. We'll have to split the data. So you can see the data with the big square on the left with all features. TV, radio, newspaper, we'll call it as X underscore train. These are our features. Actual sales is our label. We will call it as Y underscore train. So X underscore train, Y underscore train will be the two data sets. So Y underscore train will only have the measure or the target actual cells. X underscore train will have the features, TV, radio, newspaper. And we will use these two different data sets to train the model. Once the model is trained, we are going to use X underscore test, which is about test and train is about 30 to kind of industry standard, 30 to 70% data split. So in X underscore test, we have 30% of the whole data set, but X underscore test, which is highlighted in purple, is basically only the features. but no output. So y underscore test has the output. So we're going to use x underscore test, the features, to predict the cells. So that's my predicted target in blue. Once I have used x underscore test, I apply that to the machine learning model, which is already trained with the data from x underscore train and y underscore train, and use the model to predict the data highlighted in blue. Now, once I get my predicted values, I will compare the predicted data with y underscore test, which is actual cells I already have. I know what those actual values are. Now I will compare these two and try to find out what is the prediction, or how good or how well is the model behaving. So let's just go through the steps again. Split your data to train the model. The features stay in X, target stays in Y. So in this case, we have actual cells. Divide the data into features and targets. Split the features, X train, which is about 70% of the data, X underscore test, which is about 30% of the data. This X only has features. Then split the target, which is actual cells, to Y underscore train and y underscore test, which is about 30%. So I have that over here. The train test split of data is usually 70 to 30. Use the train data set to train the model. So you are going to use the 70% data x underscore train and y underscore train to train the model. So, and your train data set contains both features and targets. Just for ease, I've mentioned over here. And use test data set x underscore test, which is about 30% of the features, to or the input, to predict the target. Your test data set does not contain any target for now. Note, for our train model, the test data is new, and it has been trained on only the 70% of the data. For model evaluation, compare, and finally, for model evaluation, compare the test target y underscore test with the predicted target. So that basically should tell you how good your model is behaving. Now we will go back to the Databricks notebook just to see how we're doing the test split. So execute this. So this is, you need all these Python libraries. Scikit-learn is an open source and very popular machine learning library in Python, and I'm using matplotlib for some graphical plots, graphs, and all. Matplotlib is also quite popular. So get all the libraries installed. Then the define features and target, as we discussed from the slides, we have x is equal to df, ID, TV, radio, newspaper. Y is equal to sales, that's my target. X is my features. Now split the data into training and testing sets. We said x underscore train, which is 70% of the features. Y underscore train is again 70% of the features. X underscore test is 30% of the features that we're going to use to predict, and then compared with 30% of the target, y underscore test, with the predicted results to get our machine learning, to evaluate our machine learning model. So you can see we did x and y here, and we're passing the x and y, and we're saying test size 0.3, which means train the model with 70% data and then test the model with 30% data. Random state 42, you can give any number like 40, 42, 101, 32, whatever. This randomly selects or splits the test and train it. So you can give any number, just for reference again, 42. Now, this is the place where we register and train the model. Let me go back to the slide. So we have to train the model, provide a signature to the model. What is a signature? Signature is essentially the input and output parameters, what you are providing to the model as an input and what you get as an output. and get the log model parameters. Like, for example, when the machine learning model has run, what is the outcome, and so on, time, what server, and so on. And then register the model for reuse by other data engineers. So why do you need to do it? So once you have a model ready, so for example, in this case, we prepare the model, and then a different user from a different notebook with a different data set, if provided access, can utilize the model for its own predictions. And then finally, we are going to productionize the model. Like if you're happy with a model and its performance with different data sets, and then you say, okay, I'll provide an alias to the model like champion, production, etc. So that's basically productionizing the model. You can call something as dev, test, and production, and so on. Let's go back to Databricks for now and run the model. So this is a Python function where I'm training the model with train test and xtrain x test and ytrain y test, the experiment name. What is an experiment? So we'll go back here a little bit later. The experiment is basically where you trace all the machine learning flows, when it was run, with what parameters it was run, how much time it took. So basically it creates a log for you, and then the model name. So create the experiment if it doesn't exist. So I'm basically checking if the experiment exists, then it 3 minutes ago, less than 1 second. So I have run this. And then train, so we're basically saying, creating the experiment here, then training the model. Now see here, model is equal to linear regression. Linear regression is the machine learning model. That's one of the simplest and very old, well-known machine learning models. So X train and Y train, I'm passing in and training the model. I'm trying to get a score from the model. So basically the score is how well the model performed. And you have infer model signature. So the signatures basically provide the input and output parameters. And then finally log everything that came out of the model so that you can go and have a look. And so in the next step, I've run already the function. So now I'm going to, the experiment name is called, I've given it advertisement experiment, and the model name is advertising sales model. So let me run this for you. So maybe I have some errors. Let's run these steps again. We're good now. So maybe I didn't run a few steps. So now my experiment name is basically advertisement experiment. My model name is advertising sales model. Then I am running the function that we declared above, and the model is ready now. So you can see I have the model has been registered. Sales model already exists because I've run it already 11 times before. It created a new version of this model, which is version 12 of the advertising sales model. Now let's run a statement here to see how many versions or all the versions of the model. To get all the versions of the model, I'm saying here, so version 1, 2, so the latest one that we created in the previous step is version 12. Now your model is ready to use. Now in the next step, we discussed, let me just go back to the slide. Okay, we'll come back here later. We're back in the Databricks again. So we said we are going to assign an alias to our model so that someone else let's say in your company, if you have something like productionizing a model is called a champion or production, or if you're sending it to a test environment, test or whatever. So I'm creating a function over here to create an alias. So basically you give it a name. So in my case, I'm calling it champion. Now here so this is a function, and I'm calling the function to assign champion, or you can call it production, to your model. Right. Now we can go back to our catalog. This is important just so that you know, and you know where to look for your machine learning models, your experiments. Let's go to the experiments first. We're here in the experiment. So you can see just now, 2 minutes ago, I created a model, and this was data read from Datasphere, and how it took 12 seconds to create the model. So if you click on it, it gives you more parameters, and there is a score. So this score is how well the model has performed. So we'll just go back to the slide again, and I'll show you a different value for the score, a bit of an explanation as well. So that's how the model has behaved, and these are the different logs for the models. You can see model metrics. I don't have much, but you can come over here. You can say log model was scikit-learn, and different versions, time. So basically this is the logging. And now if you go to the catalog, go to the Databricks workspace, go to default. This is your sales model. This is version 12, which you created just now. If you go over here, you can see the alias we attached to it, and it's called champion. I'll just go back again, one step back. You can see there's only one alias over here. You can give different ones for different versions if you want. So going back again, and it has a input parameter, ID, TV, radio, newspaper. While training the model, we pass these parameters, and output you have decimals basically. So our model is ready. Now let's go back to the slide. Let me just go back to the workspace again. In the workspace, keep it clean, go to Datasphere. Now, either me as a user or you as a user or a different user comes back here and creates another notebook, and we'll try and mimic a different user who will read a different data set from either Datasphere or import it from Excel or wherever, and we will try and use the same machine learning model to get a prediction on a new data set. So the first step that we need to do, we do install SAP Databricks. And in the meantime, this is going to take about a minute. So let's go back to the slides. So we are on a different slide now, reading the prediction parameters, how well my machine learning model is behaving. So for now, I have ID, TV, radio, newspaper, sales, and predicted sales. Now I gave it the input ID, TV, radio, newspaper, sales was there, and I'm getting a predicted sales and then comparing sales with predicted sales. There is something called as coefficient. What does coefficient mean? Coefficient means, let's just focus on TV, radio, newspaper. If I hold radio and newspaper as constant and increase TV by 1 unit, what impact it has on predicted sales? Let me just repeat again. Let's say I hold radio and newspaper constant. I increase the TV cost by 1 unit, then what impact it will have on predicted sales? So we'll have coefficient, basically we're measuring coefficient for these three input parameters like TV, radio, and newspaper. You can see Here radio has, if one unit, if TV and newspaper were to be constant, if radio had a 1 unit increase, then it will have an increase of 0.18 in terms of sales. So it's important now from this model or from this data set, what I understand is radio is the one where I should be spending more money to generate more sales. Okay. So that's coefficient is one of the measuring parameters coming out of a machine learning model. The next one is model evaluation metrics. So what is model evaluation metrics? We have basically MAE, mean absolute error. That's just average of absolute difference between actual and predicted values. So it's just an average between the differences, actual and predicted values. Then mean squared error, that's average of square difference between actual and predicted values. This is a bit more popular. But then you have RMSE, root mean squared error, which is square root of MSE. This essentially penalizes larger errors. So let's say here I have 10.6, here I have 21.6, then it's a larger error. And if I do the square root, then it's going to get a higher value. But these meaning out of, there is no low and high value of this. It all depends on prediction. For example, if you want to predict the probability of fraud in a data set, then RMSE might be more relevant because those you want to penalize the wrong predictions. But if you're trying to get predicted sales, maybe mean absolute error, MAE, is fine for you. So, but more or less, these are evaluation metrics and the coefficient. And let's go to the, experiment and model score, which we just spoke a little bit earlier. Experiment on Databricks refers to a ML flow experiment, which is used to track machine learning runs, including parameters, metrics, and artifacts. Experiments help organize and compare different model training runs in Databricks. Model score refers to a numeric value that represents the model's performance or confidence in its prediction. So model score is like a bias, a minimum score. So again, based on your data, you can decide whether a model with a low score is good fit for you or a high score is fit for you. Okay, let's go back in the meantime. So the next one, we have like, we're going to mimic another user. We are going to use the trained machine learning model with a new data set because we have already registered the model, we've made it available, it's active. Now, anyone else with the required authorization can come back and run the model. Now let's go and run the model. So our installation of SAP federate Databricks has already been installed. Now let's run this. So this is my configuration connection parameters to Datasphere, then import the required libraries. Let me just clear it. So check that the connection is okay and display the InfDB connection information. So here are different methods which are available. And next, let me just clear this output. So I'm just saying, get me all the views from my test schema. We have already done this from the previous notebook. So it gives me all the views, and then I am reading the data again from the view. So then convert. So in this case, you can see I don't have any filters. I'm just reading the same data again, but I will pass on a different data set to the machine learning model. But you can have filters, let's say, where you did that for 2024, the sales data, and now you want for 2025 or any other filters. So now again, we do that conversion from PySpark to Pandas and convert everything basically from float to decimal. Now, machine learning libraries, we have done this step before, so I'm inputting all machine learning libraries. Now, define the features and target again. Now, split the data. Remember, I need my test data to be able to perform the model evaluation. So, and then I need the model details. So from MLflow, I'm importing the MLflow client. So I'm trying to get model version with the alias champion, and then print the model version. Just you can see, I should get see this one changed. Now I have a higher model. Last time when I run it, if the champion was with version 11, now it's 12. Now I need an identifier, so that's called a model URI. So uniform resource identifier in machine learning flow, so that I can invoke the model. Now I'm invoking the model, and I have, this is the unique identifier of my machine learning model with alias champion. Now we will load the model and run the predictions. Now I have run the model. Remember, by default, I'm not training the model anymore. I've just run the model and passing my test data and getting the predictions. And these are my predictions for the new data set. Now, model intercept, this is another concept. Again, model intercept is kind of, the intercept, often denoted as B or bias term, is the value of the predicted output when all input features are 0. It represents the baseline prediction of a model before considering any input variables. Okay, for example, you can't say a low value or a high value is good over here, primarily because if you have something like, let's say you want to buy a house. If you have features like kitchen, bedroom, garden, and so on, then if these features are absent, then in that case, you are going to say the value of the house is 0. So the baseline price for a model like that, if you're predicting house price with features like bedroom, bathroom, kitchen, living room, if nothing is there, then the price would start from 0. But let's say gold ornament, or let's say total hospital cost. Let's take the gold ornament example. That's better. If we take the gold ornament example, let's say you're making a necklace with a certain design. So if you don't, let's say the design features, there are 5 different features for the necklace. If none of those features have, if all those features have 0 as value, then your base price is basically 70%, roughly 70, 60 or 70% of the necklace, because the raw gold has a price. So this intercept, making a meaning out of this intercept would very much depend on your data set. Now, the coefficient we have already discussed. Each unit increase of TV, radio, newspaper, what impact it has on the predicted sets. So what we have seen, radio, again, with this data set also, radio has the highest impact on the predicted cells if there was 1 unit increase of it. Now, MAE, MSC, RMSC, MAE is just the mean average between predicted and actuals. MSC means squared error, and RMSC. So again, depending on your data, you can say root mean squared error, where there's a it punishes the larger errors. Is more fit for me. Suppose you're predicting if a patient will have cancer based on 20 blood tests. So in this case, RMSE is probably appropriate for you. If you're just predicting cells, which is not that critical, maybe MAE means mean average error is okay for you. Then now it's time we take our predictions back into Datasphere so that we can report via SAP Analytics Cloud. So now we'll do a complete prediction. So remember, in this notebook, our mimicked user is not teaching that or training the model anything. It's just trying to utilize a trained model. So it brings in all data set and then creates a prediction and add it to the original data set. So I'm saying model.predict. So I'm passing in all features of the whole data set and predict the cells. And next is, I'm just rounding it up with 2 decimal places. So now in this data set, you can see I have my TV, radio, newspaper, my record ID, sales, and my predicted sales. Now I have to take the data back to Datasphere. So what you can do in Python, we have a very important library, matplotlib. Before you take the data back into Datasphere, you can do some analysis over here. For example, here I have tried to draw a scatter plot, and you can see the actual and predicted cells. So for any machine learning model, for us to call it a good model, if your dots, like the predicted cells and actual cells, if these dots fall around the correlation line, it's a positive correlation. If it falls around the correlation line, then it's a good model. So you can do your analysis. Matplotlib is a quite popular Python library for any kind of graphical analysis. So now moving on to the next one, you can create a table in Datasphere in your space. I have already created my table. You can see the code here. So basically your connection.create table and primary key and so on. So, and then I'm not going to create my table because it's already created. Now, what you can do over here, you can insert your data frame, all the predicted and actual cells back into Datasphere. Okay, so we're going back into Datasphere. My table is already created. The data is already inserted. So here, I've created a sample view on the table that I have created from Databricks. Now you can see I have ID, TP, radio, newspaper, sales, and my predicted sales value. And of course, you get the time of insertion of the record from Databricks. Now it's a simple view I've created with all fields I've taken on, and my view is exposed for consumption. I've exposed it because I can use this view to report on SAP Analytics Cloud. Now we take this back, and here is my SAP Analytics Cloud story. You can see a simple table. In this table, I have TV, radio, newspaper, then actual sales and predicted sales. I have an absolute value difference between actual and predicted sales. So I'm saying basically if there is a difference of 0 to 1, then it's 1 to 2, make it a warning. And anything, if there is a difference of more than 2, it's a red. So it's not a good prediction. And anything else, basically it's all green. Anything less than 1, 0 to 1 is basically in green, it's all fine. Now you can see the scatter plot, similarly what we saw in Matplotlib in Databricks. So you have to, if your dots, like all your prediction and actuals, kind of fall near the positive correlation line, then we're good. It's a good model. So this model is a good model. So now we have done the exercise, but it will be worth mentioning about the new product released by SAP, SAP Business Data Cloud. It's a fantastic product, and I can take you through few key features in the SAP Business Data Cloud product. And our SAP colleagues, Philip and Andreas, have already given some insight to the product. And my colleagues from Westernaka, Mark and Claudia, they've also basically given more details around the product. Now, my take on the product. So the key innovations here, the foundation service, the storage cost and performance, which was a challenging task as far as HANA was concerned, has been resolved. So we have structured and unstructured data stored. So basically the foundation service layer. So what we have, let's just come back to the architecture a bit. We have in the foundation layer, we have the foundation services, and underneath we have the source system, and we have the business data cloud bit. So it kind of mirrors your business content from the BW world, SSE world, or any other SAP data product. Then you have Datasphere, then you have Databricks, and the data provisioning cockpit, which will enable you to get data from your existing BW systems if you're on a private cloud edition. And on top of that, you have SAP Analytics Cloud and Insight and Dashboard. So in the foundation service, what SAP has tried to answer here, the storage cost and performance, you can have the structured and unstructured data stored in files. So basically, these are Delta files in Parquet format, which are capable of petabytes of data, low cost. It's basically low cost file storage system, which is the industry standard on which AWS, Azure, Google Cloud will still run. And the performance will be incredible. I believe the customers will have a choice to have it on AWS, Azure, or Google Cloud. And this will be a fully managed service called SAP HANA Cloud. Then in the foundation service, this is the magic bit. In the foundation service, you will have an SQL engine, which will enable reporting via SSE or query via Datasphere and SQL. You can basically SQL the data in the foundation service also via Databricks. The role of Datasphere, it will be running on HANADB, modeling, transformation, and storage. All you can do as you used to do before on Datasphere. Now, the brilliant part, Databricks is in picture now. So it's for all your AI ML workloads. So with the introduction or the integration of Databricks into SAP Business Data Cloud, all the settings, configurations we showed during the demo, that will reduce significantly, because you can expose your data from foundation services into SAP Databricks, and then you can run your AI ML models from SAP Databricks. Now, as usual, we have a fantastic reporting and planning product, SAP Analytics Cloud, which is also integrated into the SAP Business Data Cloud. With that, I will conclude this session. Hope you had a good time learning how to integrate Databricks and SAP Datasphere. And with the integration of Databricks, we will even go further. Thank you very much for being patient and going through the learning process. And hopefully you enjoyed it. Kindly get in touch if you have any other queries or if you want to get more insight around SAP Business Data Cloud and its innovations, etc. Thank you.